So, if we start off with a nice round ball of clay, we can split it into two pieces. And with each of the two new pieces, we can make two more, giving us 4. Now, is there a point at which we can stop doing this? Can we keep doing this forever? Or is there a point at which we end up with a bit of stuff that can be made no smaller? So it turns out the universe does come in little pieces. Inside each of us, there are over 10 billion atoms, ranging from the lightest element, hydrogen, to heavier elements like carbon and oxygen. So are atoms as small as it gets? Well, if we look even closer still, we find that atoms are made of tinier components. So to help us keep track, I've brought along a bunch of everything that we know to exist so far. So meet the Standard Model. So let's take ourselves on a journey inside the atom. On our first pit stop, we find electrons. And these whiz around the nucleus of protons and neutrons, and they're held in place by the electromagnetic force. And little packets of energy called photons are the messenger particle of this force. And if we delve ever deeper still, we arrive at the nucleus, where inside protons and neutrons, we find tiny quarks called the ups and the downs. Now these guys are perpetually bound together by bits of subatomic cement called gluons. And these colorful fellas are the messenger particle of the strong nuclear force. To make things even weirder, sometimes quarks can even change types using the weak nuclear force. And when they do this, they spit out super heavy particles called Ws. And this process actually happens all the time inside our sun. And when the Ws decay, they produce super elusive particles known as neutrinos. Now these neutrinos are so shy that about 10 billion of them pass through your thumbnail each and every second from our sun. Did anyone notice? So electrons, quarks, neutrinos, and a whole bunch of force-carrying particles. These are the indivisible lumps of stuff which make up the universe that we know today. And we can add in heavier versions of the electron, neutrino, and quarks, and by heavy I mean really heavy sometimes, and we get the Standard Model. So is this it then? Is particle physics a done deal? Why do I still have a job? Well, one very important force is missing here, and that's gravity. And it's a big problem. A related problem is that the Higgs boson discovered at CERN last year, here it is, although it's small, although it's heavy, isn't as heavy as it naturally could be. So to help address some of these problems, the Large Hadron Collider at CERN collides hair-thickness proton beams at immense energies. And with such an amount of energy crammed into a tiny space, it's possible to create particles that possibly no one has ever seen before. And in the next few years at CERN, we hope to have enough energy to produce some new and exciting particles. So here's to our latest and greatest collider, and a future filled with, hopefully, some exotic particles.